Hey guys, Mr. Riz here to help you out on the next part for the activity 223. We're going to be looking at part 4 here. This one's called Taking a Closer Look. Now, what you guys are going to be doing here is we're going to be looking through like the behind the scenes of everything that happens with the internet protocols that we've been going over. In order to do this, there's some websites that we can use on your Chromebook, which will be okay. But if you are able to use like one of the laptops, if you have your home computer, if you could go through and install Microsoft Video Studio Code, or I probably said that wrong. It is linked to here on Canvas. Right here, Microsoft Visual Studio Code download for home. You can follow the installation guide if you want more steps by steps. Now, if you just have a Chromebook, you can do as much as you can with this. Keep in mind, if you're just watching the video, you might have to get a couple answered because there's a couple things that I don't think you guys are able to do on your Chromebook because you guys have like, certain filters that the school won't allow. Okay, so basically, some of the career connections we can really make with this section here are like the fact that companies and organizations need people to manage their computer system. That's where the system administrators come in. A system administrator may run setup tools as part of their job duties, which encompasses a wide variety of responsibilities, including managing user accounts, configure the hardware, automating processes with scripts, backing up data, and maintaining a secure network. You can think here at our building, basically that's Ray and Evan, or Mr. Schaffner, down at the in the library. So what we're going to be doing is a couple different tests to make sure we understand how our computers, our machines, our devices actually work going through. And so what we're going to look at first is getting your IP address. So a computer is connected to a network and basically the internet through the network interface card or the NIC. A NIC is set up using the program ifconfig in our Mac operating, if you're using Mac, or ipconfig if you're using Windows. All right, so non-administrative users are not permitted to reconfigure the NIC. But you can view the information about the configuration and the status. So we can't change anything, but we can go ahead and view it. I'm sure there's probably a way to do this on the Chromebook. I've looked around and I couldn't find it out. And it's because Chromebooks are set up to be just so basic that they don't have this. But if we're going to look at Microsoft Video Studio Code, if you open it up, we're going to go ahead and make sure we're view in the terminal. And just double check that you guys can see this. Yep. So click view, click terminal here. This is actually really good. It can run all different types of program. You can run a bunch of different extensions into it. And we are going to type in, I want to make sure, we're going to type in ipconfig because we're going to be using Windows. And I'll go back to Video Studio, ipconfig. I'm going to run here and we get a bunch. Now I'm going to make my terminal a lot bigger because we're pretty much using nothing but the terminal here. You can see we get a bunch of information here. You can see your local link IPv6 address, your IPv4, you got a subnet mask, a default gateway. You can see other things connected through Bluetooth, and you can see some other information here. Biggest information I want you guys to look at is right here, the wireless LAN adapter to Wi-Fi. So I'm on my Wi-Fi here, and there's some connectivity there we have to use. If you're, physically plugged in, it won't be the exact same, but I'm assuming most people are going to be connected through the Wi-Fi. Okay, so we're going to look at that. You should see something that looks like this or like this. Now, the numbers won't be the exact same. So if you look at this one here, our little wireless, I got, let's see, 192, 168, 237. Kind of close, but not there. I mean, everybody has a different. Remember, your IP address is basically like your phone number. If you're using a Mac, you'll get a similar upbringing that pops up like that. So the dot decimal notation in the IPv4 or the INET on the Mac corresponds with the NIC's IPv4 address, which uniquely identifies the machine's internet protocol. So we can look back at these examples here to see. What I want you guys to do here is to type in your IPv4 address. Now, if you're on a Chromebook and you don't have a computer you can test this out on, and you can't find it, just by Googling what is my IPv4 address, just go ahead and use one of these examples up here as a response. I'm not going to take points off. I get it that some of you guys just don't have the technology at home that other people have, or, you just don't have the resources. So for me, I would go ahead and I'm going to copy this here. Oh, can I copy that? I'm sure if I do Control C, maybe. Oh, there we go. Maybe, I don't know if that worked. Control V. Okay, there we go. All right, and then your IPv6 address or your INET6, if you're on Mac, corresponds to the machine's IPv6 address. So find your IPv6 and paste that in as well. So going back to my Visual Studio Code, here is my IPv6, and it looks like that doesn't seem right over there, but oh, I guess I can highlight it, but I have to do Control C to copy, Control V to paste. Yeah, I wonder, I bet that's supposed to be a symbol here, not #10, but we'll put it down. Okay, so every network interface card or every NIC card also has media access control, or the MAC address, that uniquely identifies it. So in the Mac operating system, the IF config tool displays your MAC address. The example in the figure 7 shows up like here. If you're using Windows, you'll have to run the git mac command access. Basically, there's a lot of different ways you can do this. Let's see. I don't think we can do this in Visual Studio Code. It's just like git mac, right? Git mac. That'd be kind of crazy. Oh, actually, yeah, it did. Cool. That works. So git mac command, run it in there, and we get our Mac right here. Right. So you can see your MAC address is composed of 1, 2, 3, 4, 5, 6 2-digit codes. In mine, I got 1, 2, 3, 4, 5, 6 2-digit codes. And I think they're all hexadecimal. And so paste those in there. Okay, so now we can kind of find information about our NIC card. Next, let's talk about looking up a domain name. How does that work? So how do I type in, if I type in canvas.com, how do I connect my IP address to the IP address of canvas.com to get to that server, to get that information? So we can recall that the domain name system, or the DNS servers, are responsible for providing client machines with the IP address of a server, such as like a website or a mail server. So the DNS hierarchy kind of goes like this. The DNS servers are organized in a hierarchy structure with a single domain at the top called the root domain, and that's designated as a dot. Okay, the next level includes the top level domain servers. So each top level domain name server in the hierarchy is an authoritative DNS server that is responsible for knowing the IP addresses assigned to its name server. So we go to the servers here, and it's going to tell us, okay, are we going to the com or the org or the edu or the gov or anything else? Now, sometimes there are multiple edus. Sometimes, I mean, you can think there's definitely multiple .com servers, but it's going to tell us which server to go to. Okay. Your web browser normally talks to the DNS server without even knowing it. So we send the stuff. We don't ever see what happens, but you can also access the DNS systems directly. So on the Windows and the Mac machines, you can do the NS lookup command. Will ask you for your DNS server to get the IP address assigned to the specific domain. So in our studio code, we're going to type the following and hit enter, or you can use this website here. So if you're on a Chromebook, just look at this website here. And I think this will actually go automatically to the pltw.org. But we're going to go ahead here and do this again. So we're going to do NS lookup and basically name server lookup. And we're going to do just a generic pltw.org. I'm not sure if you guys, I probably can make this view a little larger, right? I'm going to try to make this a little bit bigger for you guys. I don't even know if I can. Hopefully you guys can see this, but press enter. And what ends up happening is we get the addresses here of the name server. All right, so the DNS server reported 2 IP addresses for the domain name of the pltw.org. And we'll double check that we got the same ones here. Let's look for like 77.237 and 78.237. Did I get the same thing here? Oh, no, I got 225, 225, 226, 225. Any of those? Okay. I wonder if you guys got the same thing. It'd be interesting to know here. I'm assuming there could be even more. All right. So why do you think it's a good idea to having 2 IP addresses for the same server, like pltw as above? Is that a good idea, or select all, basically make it? So this will allow the websites to have more images and videos on them. If one server fails and the other one can be as backup, that's completely true. So you have 2 servers to make sure that, you always have a solid connection. And if there's a lot of traffic on a given day, the load can be balanced between 2 servers rather than 1. Yeah. So really the servers don't really affect the size too much. It's making sure that the connection or the traffic is always maintained and routed smoothly. So redundancies, we're also going to have to look at that. Redundancies, like having 2 machines ready to respond to a web request, make the system resilient and robust. So 2 words used to describe software systems that are called fault tolerant. It's important because elements of the complex systems fail at unexpected times, often in groups, and fault tolerant users allows for users to continue to use the network. So you can think of multiple times, like maybe something went down, but you can still go ahead and do it. You might see a small little hiccup, but it just switches over. So hopefully, I don't know, if you think about it, if there's a spill in the hallway, we got to wait till go through and reroute it. If it just, that was the only way to get to my classroom in the back, then we might be SOL. All right. The redundancy of routing options between 2 points increases the reliability of the internet and helps it scale on more devices and more people, giving it scalability. So a little bit more on the DNS response. So the phrase non-authoritative answer is the DNS response. That means the IP address provided were from the DNS server's cache. It was not freshly obtained from the authoritative DNS or the authoritative.org or the pltw.org servers. So that means it's like from the memory, but not from the newest version of it. So using a cache instead of always waiting for a response from an authoritative server saves time and makes the data of the internet move faster. So you might also want to think of this too, is like if you go to this website often, you might want to go ahead and obtain its IP address from your server's cache. So that way you always have that and you're going straight to that connection. You don't have to go back and look that up to see if it's a new one. All right, so ensure an up-to-date data. The DNS servers refreshes their cache entries once they expire. So you go to a website, it will tell you, say I'm going to, for the first time, I'm going to ESPN.com. I go through the DNS server, it goes through all the routes there, it finds the connection, it finds the server for ESPN.com. It tells me that, okay, here's the IP address, and that IP address has like a ticking clock that says, you know what, in 30 days, let's refresh this. So like the next 30 days, we can go back and forth to that server. I'm going straight to, if I type in ESPN, I already know in my cache that, okay, I have that internet or that IP address. We go straight to it. We don't have to look up. Fingers crossed that nothing changes in those 30 days, but then in 30 days, we'll refresh it. So maybe there's like a better route, so we look through that. All right, so what I want you guys to do now here is to go through, do an NSub lookup of your favorite website and record that. And so just to show you that, we're going to get different responses here. So if we do like NS lookup and then, I do www.espn.com. Okay, that's a really generic one, but okay, you can see I got actually several addresses here. So basically the non-authoritative answer, you guys can go through here. I'm going to try to think like if there's a website I probably haven't been to okay, I can think of one. NS lookup www.myspace.com. I haven't been to MySpace in probably 13 years. So see, okay, it actually, see, the DNS server was timed out after 2 seconds. So, all right, so that's something just to show you. Maybe they were actually, that was from my cache here because I've been to ESPN.com. I've been to Project Lead the Way. So maybe go ahead, try to think of some website you haven't gone to ever, just to see the difference between the two. But copy your results in there. We'll move on to the next part. Okay, so the next part here is that we're going to work on the DNS servers or the background work. So what's going on with those DNS servers? Like we know it goes from one thing to the other, but like really it's going through a lot of different connections. What we can use is use the dig command and the program with the .trace option as shown as below. So you can use the dig tool if you have the Visual Studio on Mac. However, it is not installed on the Windows. It says like you can go through, and I looked for it like literally days trying to figure out how to do this dig pltw.trace. And so what we're going to do here is to just look at this dig web interface. So this is a website where basically it automatically goes in. So I'm going to go here, and it's kind of the same thing that the dig command in Microsoft Studios would do, but somebody's basically made a website that does it on its own. I'm going to do pltw.org, And I'm going to make sure I click trace here so we can trace all the routes. So what's going to happen is we know that we're going to go through here, basically go to our root, a dot server. The dot server is going to go through and say, okay, you're going to go to a .org server. Your .org server is going to tell you go to your PLTW, and then your PLTW is going to go ahead, get the IP address that you're looking for specifically, and then send that back to you. What we're going to do is to trace or dig all this here to see like what happened, along the way. What servers did we hit? And you can actually see here, these are all the servers that we gone to. So we have all of our dot servers here that we went through and try to go through and which one's going to tell us the .org. And it went through and received 228 bytes in 38 milliseconds. And then through that, it went through our .org servers, and it went through all of those there to find the PLTW one. It went 432 bytes in 33 milliseconds. Once we went to our PLTW.org, we went through that one to find the www version, which is what we're looking for. So 85 bytes in 36 milliseconds. Then we got our PLTW.org, and you can see those are the IP addresses that we found. All right, so basically here, we can get all that information. So going back to this here, and we get a similar outputting here, you can see. And you can do this with other different ones too. So if I did, www.espn.com, dig that, you can see, okay, I went through the dot servers to .com to .espn.com to www. Let me see if I can, you know what, let me try to go. I'm going to pause and see if I can find a more specific website. All right, let's give this a shot. I'm not sure how well this is, but I got a https www.ign.com/article/WandaVision theories, lingering questions, episode 6. Okay, just watching some WandaVision, but let's dig and trace this one here. All right, yeah, the URL will not work. All right, let's get rid of the https. Let's dig that one here. It's still too long. You know what? I want to go /articles. Let's just do that. Okay. I guess it's not working. On the other one, and actually it is kind of going through, and we'll tell you a little bit more. And specifically here, we can go through our, well, I guess it goes through the IGN.com. Wanted to see if there's another one. I'm going to pause and think if I can think of another one that would be a little bit more specific than this. Yeah, the only one I can see here would be like if I did docs.google.com. So we still go to our go to the .com, go to google.com, and then inside that we can get to the docs.google.com. So just kind of moving through the folders there. All right, so the output displayed in both of these are evidence show that the repetitive calls made to the DNS servers at the different levels of the DNS hierarchy necessary to find the website's IP address. So all this data occurs every time you request a web address. Remember, requesting a web address is looking for a new one. So that's ignoring the cache. Okay, next thing what we can do here is to measure the ping. So the ping command in both the Windows and the Mac operating system is another commonly used tool to see the behind the curtain in a computer network. So the command measures the latency of a network connection. So it's a simple protocol. One machine repeatedly sends a packet to the other machine, so just one packet, and it's asking for a response or an echo. So the target machine responds. So once it's completed, it reports how long each round trip took and whether any packets were dropped. So we can note on just a Windows system here that the ping command runs 4 times, sending a total of 4 packets. In a Mac operating system, the ping command basically runs forever. So you need to kill the ping process to make it stop executing. All right, so what we're going to do here is we're gonna ping a website here, and maybe we'll try to see like different ones on how they look. So let's do this. I'm gonna ping pltw.org. So ping www.pltw.org, and you can see here it's sending 32 bytes, 32, 32, 32, and you can see different times here, and it's kind of interesting. 29, 239, 41, 483. So you can see here it took 4, sent 4, received 4, 0% loss, and you can see the average of 176 megabits per second. So let's ping another one. Let's ping ESPN.com. See kind of the comparison between that two. All right, so kind of the same thing here. That one took a little bit longer to do. Let me try to do something more obscure. Let's see how MySpace is doing. Doing all right. So MySpace actually looks a little bit better than ESPN. Maybe traffic's a little slower here. This is always a good one, www.chemisd.com, I believe. And, ooh, request timed out. Is it chemisd.com? I always forget, or is it chemisd.org? Let's look up chemisd. Oh, what is it? Oh, it is. Okay. Well, there's some of the things. chemisd.com just completely timed out. So not a good. Should we try that again? Oh, yeah. Request timed out. Every single one. 100% loss. Ping. www.chemisd.com. We'll try it one more time. We got the IP address there. Request timed out. Oh, no. That is not a good sign. Timed out again. Timed out again. 2 times in a row, 100% loss. Let's just double check that this is not working. Let's go to canvas. Oh yeah, we'll go to canvas.instructure.com. I don't know if I spelled that right. Oh, request timed out. Oh no, this is not a good sign. I wish I could kill this a little bit early. I'm wondering if I actually typed that in right. I guess we can always go the tried and true. Let's go to ping on ping www.google.com. All right, Google's working here. And it's actually pretty good. Okay, so the ping just kind of shows us how well we get. So depending on where you're at, so sometimes the round trip, like this one took an average of 62 milliseconds. Depends on your machine. I'm kind of in the one corner of my house, so I can see why they'd be a little bit slower than normal. All right, now we can trace the path of the IP packets as well. So every packet that was sent through the internet is passed through from one router to the next. So it's machine going to machine going to machine, all right, till it arrives to its destination. The tracer utility on Windows or the trace route utility on Macs asks the computer along the way to report back the sender. The sender then can see the hops that the packets are taking until they reach their destination. So what we're going to do here is we're going to tracer something else here, and we'll do pltw.org since we've been doing that. And maybe we'll also do ESPN here, but tracer RT, right? Is that what I do? Tracer RT. Yep. And then we name our domain choice. So I'm going to stick with www.pltw.org. And okay, maximum of 30 hops. And this one will take a second for it to kind of print off there. So you can see what it's doing here is actually naming the IP addresses of each hop that it's taking. We'll see how many it takes to get there to its final destination. So remember kind of going through a packet here, we had our dot servers, then our .org servers, then our PLTW server, then our www.pltw.org destination. All right, there we go. And we can see the trace was complete. That IP address looks a little familiar at the end. So we got 10 of those along the way. Now, some of those you guys can see here, each one of those, it took longer than before because we're going back. We're not just going straight to that. We're recalling back and giving some information. Okay, so what do you think the maximum of 30 hops meant? So does it indicate the IP packet is dropped off and doesn't reach, the IP packet is dropped if it doesn't reach a destination in 30 hops, or it's the max number of IBUs in the delivered packet? This was a sad joke by me, but here we go. It is the IP packet is dropped if it doesn't reach the destination in 30 hops. So if it takes more than 30 connections to get to it, we just kind of say that that's too much. So maybe that's the problem with ChemSD. You know what? Let's kind of mess around with a couple things here. Let's do that trace RT. Let's try ESPN. We know that's been pretty reliable. See if we get kind of a similar result. And I'll pause so you guys can see the results at the end. All right, I'm going to call it one on the ESPN. I'm just noticing right here that I'm getting a lot of requests timed out. I'm probably also in the, what I said, I'm in the corner of my house with the Wi-Fi, and there's also an ice storm kind of going on right now. So yeah, I'll leave this going in the background. We'll see it goes through. So what does the rest of the opt-out illustrate here? So basically, when we look at this, what happens here? What does this illustrate to us? Does this show like each of the IP addresses and the time represents a different route a router traveled to by the packets and the time it took for each hop? Or it is the IP address of the linked websites on the page? So yeah, it's not like what websites you can go to or what, what is the IP address? It's not like, okay, if I click this link here, what is that IP address? It's basically we're going through and determining the routers along each way. So when you guys get this done, go ahead, submit the quiz. Now, there will be several answers that I will have to go through and submit, but we'll go through, check that, and we'll see how well you guys did. All right, guys, so this was a long one, a lot of information, but it's actually kind of pretty crazy when you think about everything we do and all the behind the scene works that we don't really ever think about. All right, guys, have a great one. I'll see you later.